Well, in the video prior to this, we talked about orbitals and we talked about where all the electrons could go. Today, we're actually going to start putting electrons into those orbitals and understanding how exactly they go about filling those orbitals up. The periodic table is an absolutely crucial piece of information for you to have in order to do this. And while I have one up here, I realize it may be a little bit small for you to be able to see. You may be able to make your screen a little bit bigger, or probably the most helpful thing will be to make sure that you have your copy of the periodic table on the desk in front of you as we're walking our way through this. You will recall that there are, for our purposes, 4 different orbitals: an S, a P, a D, and an F. And there are more than that, but we're not going to deal with anything any larger than those particular orbitals. So if you look at the periodic table, and there is a chart of this in your book as well, the first 2 columns on the periodic table that I have outlined in purple up here are the S orbitals. They are the lowest energy level, or the lowest orbital on an energy level as far as energy is concerned, and they are the ones that fill up first. The Aufbau Principle that your author stated means that electrons are always going to go into the lowest possible energy level. So another way to think about that is that if you're in a hotel, people are going to want the rooms on the lower level first so that they don't have to haul their luggage up the flight of stairs. So that might be one way to, very simplified illustration, but might be one way to think about that. So the lowest possible energy level, or orbital on an energy level, is the S. And for this particular exercise, we need to take helium and we need to slide it over into this S block. Helium's a really special element. It only has S electrons, but it behaves a lot like the other elements in this column, which we'll discuss a little bit more later. So just temporarily, we're just going to slide it over here so that it makes our electron configuration system work a little bit better. Okay? The next highest orbital as far as energy goes on an energy level is the P that I have outlined in green. And so you'll see that there are 6 columns over here that takes into account. The D orbitals are in the middle, and then the F orbitals are down here on the bottom. Now, what does all that mean as far as actually putting electrons into these orbitals? Well, we're going to do a few examples. If you have the sheet that I provided for you and you have it printed out, I would like for you to fill it out with me as we go along so that you'll get practice in doing this. We're going to start with the very most simple atom, which is hydrogen. And if you remember how to determine how many electrons are in an atom, you're going to look at the atomic number, which on the periodic table that I gave you is the number 1. Remember, it's not the decimal number, it's the whole number that you're going to see in the boxes. So 1, helium is 2, lithium is 3, beryllium is 4, boron is 5, carbon is 6, and so on. Okay, so hydrogen has 1 electron. And so it's going to go, that electron is going to go in the very lowest orbital in the very lowest energy level. The row numbers over here, 1, 2, 3, 4, 5, 6, whatever row that the element is in, the row number corresponds to the energy level as well. So for hydrogen, it's in row 1, which is energy level 1. It's in the S block, and it's in the first column. So that means there's just going to be 1 electron in the S orbital. So you have 1s1. Energy level 1, S orbital, 1 electron in that orbital, which makes sense because I have 1 electron total. Now, I'm going to look at helium next. Now remember, we kind of took helium and slid it over here so that it would fit and make sense. Helium, the atomic number on it is 2, so there are 2 electrons to fill. And because there's still space in this orbital, because I can put 2 electrons into each orbital, there's still space in this one. So the row number is 1. I'm still in the first row. I'm still in the S block, but now I'm in the second column and I have 2 electrons in that energy level. Okay, so 2 electrons, which matches my 2 electrons here. Lithium is over here. Lithium has 3 electrons. Now, the author talks about walking your way through the periodic table, so I'm going to try to show you what he means by that. You're always going to start at the top and say the electron configuration until you get down to the element that you're talking about. So the first row on the periodic table gives me 1s2 if I fill that up completely. Lithium is actually down here, so I'm now in the second row. I'm still in the S block. I'm in the first column. Okay, so I've got 1 electron in the second energy level and 2 electrons in the first one. Now, if you add up all these little superscripts, you should get the total number of electrons. That's going to be one good way to tell whether you made a mistake or not. Okay, beryllium is the second one over. Beryllium has 4 electrons because of that little number down there on the periodic table. So I'm going to start at the top again and walk my way through. So I'm going to have 1s2. Beryllium is on the second row in the s orbital. It's in the second column. So what that means is I've got 2 electrons in the 1s orbital, 2 electrons in the 2s orbital. 2 plus 2 is 4. Okay, let's look at boron. Okay, now I'm over here in the p orbitals for the first time. So in the p orbital, boron has 5 electrons. Again, we start at the top, we work our way through. So 1s2, 2s2. Now I'm over here. I'm still in the second row, but now I'm in the p block and I'm in the first column. So it's 1s2, 2s2, 2p1. And if you add these up, 2 plus 2 plus 1 gives me 5. Okay, carbon. Carbon has 6 electrons because that's the number that's down here as far as your atomic number goes. Again, you start at the top. 1s2, 2s2. Carbon's over here. Now I'm in row 2. I'm in the p block. And I'm in the second column over, so that's another 2. So that means there's 2 electrons in the p orbitals. So 1s2, 2s2, 2p6. If I add up the superscripts, 2, 4, 6, which matches right here. Okay, let's skip a few. Let's go to neon, which is at the end of this row over here. Okay, again, you're going to start at the top. 1s2. Next row down, 2s2. Neon is here. I'm in the second row. I'm in the p block, and it's the 1, 2, 3, 4, 5, 6th column. So there are 6 electrons. Now don't get confused here because we said earlier that you can have 2 electrons per orbital. If you remember, there are 3 p orbitals. There's a p orbital that goes this way, there's a p orbital that goes this way, and there's a p orbital that goes this way. So each one of those orientations, I can have 2 in this one, I can have 2 in this orbital, I can have 2 in this orbital. So that makes a total of 6. So that's why in your p orbitals you can get all the way up to 6 because you can put 2 in each one of the orbitals. Okay, and neon, as you can see, has 10 electrons because that's what its atomic number is. Okay. Let's go down to the next row. Now I've got Na, which is sodium. Sodium has 11 electrons. And so if I walk my way through again, you always start at the top. 1s2, second row. 2s2, 2p6. I'm now in the third row. Sodium is in the S block. It's in the first column. So 1s2, 2s2, 2p6, 3s1. Okay? Skip over to sulfur. Now I'm right here. You always start at the top. So sulfur has 16 electrons. So I'm going to go 1s2, 2s2, 2p6. I'm now in the third row because sulfur's in the third row. 3s2. Sulfur's actually in the third row in the p block. 1, 2, 3, 4 over. So that's going to give me 3p4. Okay? 4, 5, 6 plus 6 is 12, 13, 14, 15, 16. So I've got 16 electrons. Okay? It should all add up by the time you get done. Okay? Calcium. Again, you're going to start at the top, but now I'm in the fourth row now. So calcium has, if I could see it, has 20 electrons. So again, you start at the top, 1s2, second row, 2s2, 2p6, third row, 3s2, 3p6. Calcium's in the fourth row, in the S block, in the second column. So it's 4s2. Okay? Now, when I get to iron, you have to be careful because this is the first time I've been in the D block. And if you recall, I said that on the third energy level that I had an S orbital, a P orbital, and a D orbital. And so initially, maybe this confused you because my D orbital's not in here anywhere yet, and I've already gone up to the fourth energy level. And the Aufbau Principle says, well, you have to fill them up in order. Well, the trick to all of this is that even though the D orbital is technically on the third energy level, it's actually got a higher energy than the 4s orbital does. And so the 4s orbital fills before the 3d orbital. And I know that sounds really confusing, but what you have to keep in mind is that as long as you're reading your way across the periodic table, you're going to be able to get it in the right order. Okay? So, iron has 26 electrons. And again, I'm just gonna read my way across the periodic table in order to get here. So I'm gonna have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now, when I get here, whenever I get to a d orbital, I have to take whatever the row number is and I have to subtract 1 from it. So this is actually 3d, even though it's in the fourth row. So this is going to be 3d, and I'm 1, 2, 3, 4, 5, 6 columns over, so I'm going to have 6 electrons in the 3d level. Okay, turn that just a little bit. Arsenic. Okay, arsenic is right here in the P block. Now, it's in the same row as iron, so everything should be the same as I get all the way up there. So I'm going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Remember, this is the 3d row. 3d, and if you count, you're going to have 10 going all the way across here, and then you get to the P block, but this is the same as the row number, so this is 4p, and if it's arsenic, I've got the 1, 2, 3rd column over, so it's 4p3. Okay, so as long as you're reading your way across the periodic table and doing it in order, you're going to have these guys right. So like I said, you're going to have the s orbital, then the 3d, then you're going to go back up to the 4p. Now, these get really, really long to write. So what we've done is there's a shortcut. Chlorine, right here, if I take the last element in the row above it, which is called the noble gas, and we're going to talk more about that in the next video lesson. If I take the element in the row above it, I can shorten this by saying it's the same electron configuration as neon plus 3s2, 3p5. So this is the shortcut way to do this one. Okay, so anytime you're asked for an abbreviated electron configuration or a shortened electron configuration, you can do it by looking at the element, looking at the row above it, the last element in the row, writing that in brackets, and then write just the last row. So if I look at strontium, which is right here, strontium's in the 5th row, so if I look at the last element in the 4th row, it's krypton. So I'm going to put krypton in brackets, and then if I look at the 5th row, I'm in the S block, second column over, so it's krypton 5s2. So those are the shortened or abbreviated electron configurations. If your head is spinning, that's not too unusual at this point. Do some practice and I think you're going to be okay. And then the next time we'll talk about why all this is really important.